Welcome to my channel. In this video we will try to repair this outdoor security siren. It belongs to my friend. I will try to open this siren. Maybe the light is okay, only the sound is missing. This is the tamper. So if the thief remove the siren from the wall, it will activate. We have here a screw. We will undo this screw first. It's still hard to remove by hand. It has a metallic thread. So we have here what we found here, those maybe for the battery. This one is missing. We will see it go to the tamper. This one goes to the tamper, and the other one, those two goes to the tamper. This is for the battery, this is for the transducer, and this is the positive for the battery. We have here 13.8 volts, so it must be a plumb battery or a 12 volt plumb battery. Here we have the two flash LED, 1, 2, 3, 4 flash LED. The tamper goes here. We have here a PCB. We will remove the PCB and see what's the problem with this PCB. So we can zoom here. Here we have the tamper. Here we have the block. This is the block, race. And those may be from the central. This is for the address. Some switch. We have a diode here, and we have four transistors. So maybe they use a bridge to drive the siren. We will see one from them. They are cut the siren to test to do a test maybe. We have the two here, two lower side for the siren. We will see where they go. This one and this one. This is a double face PCB. Probably they go to those transistors. We will see the reference of the transistor. I must grab a magnifier. Maybe I will use this one. It's not clean from the dust. I didn't see any marking. I will grab my phone. We can use the camera of the phone to see the marking. 23 maybe, or 22. It's not exactly. This is a BGT transistor. I will find the data sheet. There isn't a tip 123 transistor. Maybe yes, it is 122 is a Darlington NPN transistor, and the 123 maybe NPN transistor. We will find with the dimeter if it's Darlington or a normal BGT transistor. 122 is a normal, and here they said it's Darlington. I will test the transistor with this meter. So we go to the diode. Maybe we will angle this to get the best reading. Now we will clip the cover and test those transistors. Maybe the base from this side. I will try to find. Here we have nothing. Try from this side. Nothing. Maybe there is a coating here. We will try to see if yes, there is a coating. They use resin coating to protect the PCB from the weather, because there isn't a rubber here to do waterproofing. So we must use a sharp leads or try to remove the resin. Yes, it's a thick coating. I will try to test from this side. I will put here the we will test the middle. The middle one is connected to the heatsink, to the metallic part. Yes, we have a transistor here. We have a junction here. Maybe a Darlington. This is the base collector and the emitter. Yes, it's okay. So we have we will test all those transistors. This is the diode. This diode. Okay. The other one is okay. I will test this transducer. Maybe it may use a piezoelectric transducer or a normal speaker with winding. I have nothing. I will try to remove the transducer and see. It's like maybe there is a no screw from this side. It's fixed here. Maybe good. We can test the transducer with a voltage, for example. We will see if there is no resistance here. We can try it, because if it's a normal speaker, it can be burned with a high voltage. So we have nothing. We will switch to the ohm. Maybe it has a high resistance. Nothing. This is from the rest of my hand. Nothing. So I will try to use, for example, 12 volt here. 13 volt. I will grab the this. I will change for those one. We must hear a little noise, not continuous, from one pulse, because they inverted the polarity, and it has a maybe proper frequency. Nothing. Nothing. Maybe there is a problem with the transducer. I will grab one, a small one, to difference. For example, here you have some small transducer and quarters in this part. Maybe they use one bigger than this quarters transducer. It's used for the alarm in the clock. For example, we will try this one. If we apply voltage in the quarters here, we'll expand a few atoms, maybe 10 or not a much distance, a small distance, but it will generate a sound. And when we put the sound here, it will generate a voltage. It's reversible. So we can try this one. We heard a small noise. This one is okay, but here we didn't hear anything. I will remove the other one. It has no polarity, of course, because the voltage is inverted. Nothing. I will use my function generator to put some voltage here and to test with a different frequency. Now we will try to test this transducer with this function generator. First of all, I will test this small one, then this big one. So I must insert here this in the output, of course. Yes, we choose frequency. Here we have the frequency. We will choose, for example, 440 Hertz. And for the amplitude, we have 1.2. We will choose, for example, 5 volt. Offset 0. So now we will activate the output. We will try to use this one. It may work, it will give a little sound, amplitude of sound, because it is not 440 Hz is not the proper frequency for this one. I didn't hear anything. I will try to from the frequency. Yes, you can hear here. We have some sound. Now I will try to drive this bigger one. I will try to hear nothing. There is nothing. It didn't output any sound. So we will open this transducer and see what is the problem. Now we will open this transducer to see if it's repairable or not. I will try to. It's glued here. There isn't any screw here. There is any screw on this side. Nothing. Maybe it's glued here. Yes, it's glued. But we have a magnet here. Oh, so this is not this transducer. It's a normal speaker. But the winding is burned inside. So the problem is the internal winding. It's jumped to the scope, but it's protected with this cover. It's a glass cover, so the screen is protected. Yes, it was glued with this glue or silicone inside. Now we will open the speaker. We didn't find the resistance between those two leads, so the internal winding is damaged. You must find here 4 ohm or 12 ohm or 8 ohm if it's in a normal speaker. We will open this speaker. It's a tweeter, for example. Maybe it's better because it works with a high frequency. It may output 105 decibel. I thought it was a quartz transducer. That can be found in the sounder, for example, fishing sounder. Now I found the membrane. So it's here. We will test the continuity, but we tested here. We didn't find anything. Another test to test the leads here. They are soldered or not. They are soldered. Okay. Now we can open the other. Maybe the cut is near this part, so we can weld it. We'll try to open this cover and we see if it can be removed. Now, this winding, the problem is with this winding. Maybe it's burned from, although it's not in place properly. Must be glued here with the resin. And we can see if there is a cut. Now I will use my microscope to try to repair this speaker, this tweeter. I will zoom in to the screen of the microscope. This is our speaker, and this is the magnified picture. We have here some flickering from a projector, light projector, so I will turn it off. Maybe we will try to for this part, so I will try to remove the wire. So here our wire is here. Here we have the problem. We have now contact between this wire and the other one, that leads to the principal wire. So we must undo a turn and resolder it here. So now I must remove. I must hit the end, this end, to remove the resin. Now I will solder this tiny wire. Now I will put some solder here. I will add it must be cut. Now I will try to solder those two wires together, the tiny one with this greater wire. I will try to solder them together. They are soldered. Now we will solder this wire to the greater one. Maybe we can move this one if, but it has it's fixed with the glue. Now it's soldered. We must solder it in the lower one. It's soldered. Now we will do a test with this meter. If we have a reading 4 ohm or 8 ohm, it's okay. We can cut the excess. I will try to measure from the two sides. No, 2 omega ohm. Now I will undo this. I will cut this wire and search for the other part. This part is cut. It will be glued here. This tiny wire will be glued in this position. And we will see the other side. Maybe there is a problem here in this one, in this part. Here we have our wire. Maybe it's not, it's soldered here. Maybe there is another cut. I will try to measure in this part. So I will measure between this one, this pin, and the other pin. We have nothing. We will switch to ohm. We have nothing. So there is another cut. I will tell him to buy a new one, new transducer or a tweeter speaker with the same power, and we will do a test. I didn't manage to repair the internal winding because it has multiple cut, so I assembled it, and I will tell him to buy another speaker, tweeter speaker with the same power. Now we can at least take a look at the PCB. This is the PCB for this siren. Now I read the marking of those circuits. Here we find the 5-volt regulator, 78L05. This is the microcontroller. It's MC68HC908 from Freescale. This microcontroller drives this circuit ULN 2003, which has 8 Darlington transistor, and this circuit will drive this bridge amplifier with those 4 resistors. Also we have some diode, high power diode, maybe for charging the battery. And this is to select the address of the siren. The other side, nothing here. So before connecting the new tweeter or speaker, you must test those transistors, and you mustn't get a voltage between those 2 pins to the speaker. If there is a voltage, maybe one of them is damaged, and it will damage the speaker again. Now we come to the end of this video. Thanks for watching, and have a nice time. We will put the sticker